All right, calorimetry you may have experienced in biology, and it is a measure of the heat flow by the changes in temperature. And often you will see just styrofoam coffee cups nested together, and the reaction occurs in the inside here. Sometimes it can be a solid being dissolved. Sometimes it could be two liquids being mixed. You might see a chunk of metal put into water. And what you're doing then is, as this reaction occurs, whether it's physical or it's a physical change or a chemical change, you are measuring the starting temperatures and then you are measuring the ending temperature, and that gives you your delta T. You start with a known mass, and you either know the substances, which will lead you to a thing called specific heat, or you know how much heat. So you will use an equation, which we'll talk about here in a minute, called Q equals mc delta T, most often for the to find the specific heat and the heat. Several terms to be aware of. Heat capacity is the amount of heat needed to raise the temperature of a substance by 1 degree Kelvin. Molar heat capacity is the heat needed to raise that temperature 1 degree for 1 mole of substance. And then specific heat is the heat capacity for 1 gram. Q stands for heat. M stands for mass. Delta T is the change in temp. And C is the specific heat, which is often given to you or listed in a table. It's in our book. I'll give you the page number here in a minute. On page 181. Often specific heat is given in the problem, or you're asked to find it, and it is specific to different substances, so be careful that you're reading for the correct substance. The mass is given in grams, and then the heat would be listed in joules. And temperature can be measured in either Celsius or Kelvin because they're the same scale. Okay, so here is your sample problem. 90-gram sample of a metal absorbs 25.6 joules and the temperature increases by 1.18 degrees Celsius. What is the specific heat? All right, so we know that Q equals mc delta T, and let's plug in the information that we know. We know that we have 25.6 joules of heat, and our sample has a mass of 90 grams. We're being asked to find for C, and the temperature change is 1.18 degrees Celsius. So we have these numbers, and we can solve for C. So we're going to take the 90 times the 1.18 and then divide the whole thing into the 25.6. So 25.6 divided by whatever 90 times 1.18 is, 106.2. That will be C. When we further simplify, our specific heat is 25.6 divided by the 106.2, and you get an answer of 0.241. And this unit is going to be joules over grams degrees Celsius. Here's your homework problem that reads 4.0 grams sample was heated from 274 Kelvin to 314 Kelvin and absorbed 32 joules of energy. What is the specific heat of the sample? So I'd like you to set up and solve this problem and then upload it into the calorimetry homework assignment in Schoology.